In 5.6, our objective is to find the derivatives of inverse trig functions. So we need to do a little review first of how to work with inverse trig functions. So that's what this first tutorial is going to be about. First of all, remember the notation. Y equals the arc sine of x. That is very similar to the notation y is equal to sine to the -1 of x. They mean basically the same thing. So for the purpose of this lesson, arc sine of x will mean sine to the -1 of x, the inverse function of the sine of x. So that means that sine of y equals x. What that tells us is that when we're taking the sine of something, that is the angle. So when we read this, we say the angle such that when we take the sine of it, we get that value. That's what we think to ourselves. Now remember that functions can only have inverses, meaning the inverse will be a function, if the function is strictly monotonic, always increasing or always decreasing. So we have to consider that there's a restriction on the domain of each of these because we know that the trig functions are cyclical. For example, the sine function, all of it, which goes on infinitely, is not strictly monotonic and does not have an inverse because it goes up, down, up, down, up, down, right? So we take just the section of it that is strictly monotonic and closest to the origin. So here's the origin. So it's strictly monotonic from here to here, closest to the origin. So what section is that? -π/2 up to π/2. So we're only using those angles. So when we say we want the sine of what angle, the angles that we're talking about are this range of angles. So this range here represents the angles that we would possibly give if we were asked to find that that angle for that gives us that x value when we take the sine of it. For example, you may have a better recollection if we do some of these examples. Evaluate the following inverse trig functions. So arc cosine of -1/2 equals, we are asking what angle is it? Arc cosine, inverse cosine is asking for an angle. So normally we would say, and let's call this angle something. Maybe we call this, theta, the angle theta. So let's change this into saying the cosine of what angle equals -1/2. So we think about our unit circle, which by the way, we have to know really well at this point. On our unit circle, cosine, which is the x-coordinate, is a half where? So we think of our ordered pair where 1/2 is the x-coordinate. That goes with √3/2, and that helps us remember that is π/3. And by the way, we always do radians, okay, unless otherwise specified, but it's never otherwise specified. So always with radians. So that's the π/3 angle. But π/3 is where x is +1/2. Where is x -1/2? So we think about our unit circle, and actually there's 2 points where it's -1/2. It's up here, so the angle is up here. This is the reference angle π/3, but in the second quadrant, that's 2 π/3, but it's also -1/2 down here. What's that reference angle? Well, if this is pi and we add a third to it, that's 4 π/3. So which one is it? Well, we have a restriction on how where the angles for cosine goes. So just like we looked at the graph for sine, if I look at the graph for cosine, starts here, goes like this. Okay, we could look at it going the other way. We want just a section that's strictly monotonic and closest to the origin. That section is going to be from 0 down, 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 down to the bottom of that slope right there, that little curve right there. That's at pi. So we only look at the angles from 0 to pi. Basically, another way to think about it is in our unit circle, we want a positive and a negative quadrant. Well, for cosine, this is the cosine graph, we want the quadrant that is positive for cosine, that's this quadrant, and negative for cosine. So that's these two quadrants from 0 to pi. For the sine function, we want a positive and a negative quadrant also, but sine is not positive in this, or sine is positive in this quadrant. So whereas we take the positive here for sine, it's negative in this quadrant. So we go forward to pi over 2 and backwards to negative pi over 2. Of course, if you remember, sine is the y, where this y is positive, where the y is negative. Cosine is the x, where the x is positive, where the x is negative. Just those two quadrants. Perhaps you go back to your notes and you make yourself a little bit of a reminder about the visual of these quadrants. So for example, anything sine and related to sine, so arc sine, its reciprocal arc cosecant. Visual of that is this quadrant where it's positive and this quadrant where it's negative. That's the visual for those three, up to pi over 2 and back to negative pi over 2. And then the three other ones, the arc cosine, the arc cotangent, the arc secant, those three have the range of angles of 0 to pi. So those are going to have this visual, positive in this quadrant, negative in this quadrant. So from 0 to pi is where we look at that range of angles. So let's go back to our example and figure out which angle it is. So we remember that the cosine is positive here and then negative in this quadrant. So we're not looking at this part of the unit circle, only from 0 to pi, just the top part of the unit circle. Well, where is the cosine negative? And we set it 2 pi over 3. So our value for theta, or what is the arc cosine, it's 2 pi over 3. Do you want to try the next one? Pause the video, see how you do. So let's think of this again. Arc sine means the angle. I'm going to say equals theta, theta for the angle. So I'm going to rewrite this saying sine of what angle, sine of theta, equals negative root 3 over 2. It might be easier to think of it like that. So then we think of what ordered pair has root 3 over 2. 1/2 root 3 over 2. Well, again, that's the pi over 3 angle. But sine's restriction is forward to pi over 2 and backwards to negative pi over 2 because sine is the y. It goes up to be positive and down to be negative, unlike x goes right to be positive and left to be negative. So looking for this reference angle, we are going to be looking for pi over 3, that gives us the negative, that's down here. But the tricky thing is we don't go all the way around and call this 5 pi over 3. We're going backwards to negative pi over 2 and forwards to pi over 2. So this one will be backwards to negative pi over 3. So here our theta is negative pi over 3. Did you get it? Well, maybe you need some more practice, and that's okay. Let's take a look at some other examples. Solving for x in the problem. So the important thing here is to get the idea that arctangent is the inverse of the tangent function. So how do we get the x out of here? Well, we take the inverse of the arctangent function. That would be the tangent function. We take the tangent of both sides of our equation. So the tangent of the arctangent gone, and I'm left with 2x minus 5. The tangent of negative pi over 4 is negative 1. Again, you have to be very comfortable with your unit circle. Once those are gone, it's easy. We solve and get x equals 2. Here's another one that's not the same. So some things we want to think about that will help us in solving, besides the fact that the sine of the arc sine of theta, those are inverses of each other, is just theta because the sine cancels out the arc sine, those inverse functions, leaves us with just theta. And of course, doing it the other way works as well. So the arc sine of the sine of theta also equals theta because it's the inverse function of it, so theta is left over. Well, it's also important to remember that the arc cosecant of, let's call it x, well, I've been calling them theta, but this is slightly different, so we'll write it with a different variable, equals the arc sine of 1 over x. Remember cosecant and sine are inverses of each other, so the angle will be, not the angle, the value such that the angle gives us will be reversed. So these are some important properties to remember about the inverse trig functions and how they work together and can help us to solve equations. So let's think about how we can use it here, because if I take the cosine of the arc cosine, I also have to take the cosine of the arc secant. On the left, it helps us get rid of arc cosine, but on the right, it does not. But this property right here helps us for this problem. Why? Because cosine and secant are reciprocals of each other. So I can keep the left side, arc cosine of x, the same, while the right side becomes arc cosine of 1 over x, because it's the reciprocal ratio, and that's the ratio of the sides, x and 1 over x. Now that I have the same function on both sides, when I take the cosine of it, so now I'm going to say the cosine of the arc cosine of x, I can also do that on the right side. And now I have my inverse functions, and I'm left with just the x equaling the 1 over x. And now it's a more simple equation to solve. Cross multiply, say x squared equals 1, therefore x equals 1 or negative 1. A couple other things to recall about the inverse trig functions. Sometimes we need to think about taking the tangent of the arc cosine. Those are not inverses of each other, so we have to think of this like two problems in one. Remember in number 1 and 2, we did problems like this, where it was just like this, the tangent part wasn't there. So remember what we asked ourselves. This is the angle theta. We basically said the cosine of what angle equals root 2 over 2. Well, we're going to solve that, and we're going to say theta is pi over 4. Well, that was that part. Now I have to do the outside part, the tangent. So the tangent of what I just found right here, pi over 4, and evaluate that. So if they're not inverse functions of each other, it's going to be a couple of extra steps. The tangent of pi over 4 is 1. Done. Now, root 2 over 2 is on our unit circle. Is 5/13 on our unit circle? No, it's not. So if it's not, then we do what was suggested in the directions. Use right triangles. Let's qualify that and say only if the value is not included on our unit circle. Because otherwise we know our unit circle, we don't need right triangles. Let's think of it still like this. Arc sine is the angle. So I'm going to ask myself the sine of what angle is 5/13. Now I don't really need to know the angle, but I can visualize a right triangle. Let's do that. Draw a right reference triangle. Put theta in one of the acute angles. So here's the right angle. Theta can go in one of the other spots. Doesn't matter what you pick. Now remember SOHCAHTOA and how sine of an angle is the opposite side over the hypotenuse. It's that ratio. So 5 will be the side opposite, 13 will be the hypotenuse. Use the Pythagorean theorem to solve for the missing side. So c squared equals a squared plus b squared, 13 squared equals 5 squared plus b squared, or you remember the triple 5, 12, 13, and then you know easily b is 12. So this side missing is 12. Why do we need that side? Well, ultimately, we're looking for the cosine of what we called theta. So the cosine of theta, remember cosine adjacent over hypotenuse. Cosine is adjacent leg over hypotenuse. What is the side that's adjacent? 12. The hypotenuse is 13. So we get 12 over 13. That's how to do it using triangles. Let's look at a couple other examples that are going to be useful to you as we get into the derivatives. Write each expression in algebraic form. What does that mean? That means has no trig functions in it. No trig functions, just algebraic numbers and letters. We can do that using triangles. Just like we did evaluating it, we are going to call this stuff, the arctangent, an angle theta. So this is basically saying the tangent of what angle equals 4x. So we draw a reference triangle because 4x is not on our unit circle. Put theta in one of the acute angles. Remind yourself that tangent of theta, tangent of an angle, is opposite over adjacent. So 4x is like 4x over 1, opposite is 4x, adjacent is 1. Here we need the Pythagorean theorem. C squared equals a squared plus b squared. C is what we don't know. 4x squared plus 1 squared makes 16x squared plus 1. Take the square root. It can only be positive because it's the side length of a triangle. Negative doesn't make sense. Plug it in there. Now that we've got all our sides labeled, now we can do the secant of theta. So I say, what is the secant of theta? I know it's the reciprocal of cosine. So cosine upside down is hypotenuse over adjacent. Hypotenuse is square root of 16x plus 1. Adjacent is 1. Oh, what did I miss? How did that squared run away from me? 16x squared plus 1, 16x squared plus 1. Let's plug that in there correctly. 16x squared plus 1. I don't really need the denominator, so square root of 16x squared plus 1 is sufficient and good. Try the next one. Pause the video. Come back and see how you did. Let's check it out. Arc cotangent means I'm looking for the angle. So I write cotangent of what angle gives me x. I remember that cotangent, the reciprocal of tangent, is adjacent over opposite. So I draw my reference triangle, put theta in one of the acute angles. Adjacent will be x, opposite will be 1. Use the Pythagorean theorem to find the hypotenuse, the square root of x squared plus 1. Now we find the cosine of it, theta. Cosine of theta is adjacent over hypotenuse, x over square root, x squared plus 1. Did you get it?